ब्रो, सच बताऊं, मोस्ट पीपल डेटा साइंस गलत तरीके से स्टार्ट करते हैं। सब लोग पाइथन एमएल एआई पे जंप कर देते हैं। बट रियलिटी क्या है? अगर तुम्हें थिंक करना नहीं आता तो तुम कभी डेटा साइंटिस्ट बन ही नहीं सकते। टुडे डे 1 थिंकिंग लाइक अ डेटा साइंटिस्ट।
3, 2, 1!
So, you want to be a data scientist. Let me tell you a secret. The most important skill isn't about writing crazy complex code or building some fancy algorithm. Nope. The one thing that truly separates the good projects from the ones that fail, it has nothing to do with Python. It's all about how you think. Okay, let's get right into it. And you know who is maybe the greatest problem framer of all time? Albert Einstein himself. This single idea is the key to, well, everything. Before you can even dream of finding the right answer, you have to be 100% sure you're asking the right question. So, what happens when we don't?
Well, this happens. A mind-boggling 87% of all data science projects, they never make it. They never get used in the real world. Think about that. All that time, all that effort, just gone. It's a huge mystery, right? Why are so many projects failing before they even get started?
Let me tell you a quick story from back when I was starting out. This one taught me the lesson the hard way. My team was asked to build a model to predict customer churn. And you know what? We built a beautiful model. Technically, it was perfect. It could predict exactly which customers would churn next month. The only problem? We found out way too late that our customers were all on 2 or 3-year contracts. Predicting monthly churn was completely and totally useless. We had the perfect answer to the absolute wrong question. So that brings us back to the big question. Is it because the code is just too hard? Is the math behind it all just too complicated? And the answer, as my little story just showed, is almost always a big fat no. The project doesn't fail when you're writing the code. It fails long before that. It fails right at the very beginning. Here's where it all goes wrong. There's this huge communication gap. It's like one person is speaking a totally different language. On one side, you have the business leader who says something broad, like, we need an optimal marketing strategy. That's a great goal, but it's fuzzy. On the other side, you have the machine, the computer, which needs a super precise quantitative instruction. Something like, give me a list of the 1,000 users who are most likely to click on this ad. See the difference? That gap right in the middle is where projects go to die. But don't worry, there's a bridge to cross that gap, and it has a name: problem framing. This is our superpower. It's the detective work. It's the art of taking that fuzzy business idea and translating it into a sharp, specific question that data can actually answer. Now, to really get this, let's just forget about data science for a second. Let's think about something we all know: the local Kirana store owner, the guy who runs the corner shop. Believe it or not, this person is a natural-born data scientist, a master of problem framing. They just don't use the fancy words for it. Just look at how their brain works. It starts with a big, vague problem. Man, my sales are down. But they don't just stop there and worry, do they? No. They immediately start asking questions. The why. Why are sales down? Is it too hot outside? Wait, are people buying less soap, or is it the biscuits? And just like that, those questions lead to a super simple data pattern. Okay, this week I'm going to track how much soap I sell versus how many biscuits. That's it. They just framed the problem perfectly. Now, what that shopkeeper just did instinctively, well, that's actually a formal process. See, problem framing isn't a straight line. It's more like a cycle of questions. You start with a big problem, you ask questions to make it clearer, and those answers lead you to even better questions. It's like a spiral, and with each loop, you get closer and closer to the real core issue you need to solve. So let's turn this into a simple 5-step thinking framework that you can use for anything. Step 1, state the real business goal. What are we really trying to do here? Step 2, be like a little kid and just keep asking why, to dig down to the root cause. Step 3, make a list. What information or data do you actually need to answer that why? Step 4, and this is a huge one, check if you can even get that data. Is it available? Is it usable? And finally, step 5, translate everything into one sharp, specific data question that a computer can understand. All right, theory time is over. Let's put this framework to the test with a few real-world examples. First up, an e-commerce website comes to you and says the classic line, "We want to increase sales." Okay, where do we even start with that? So, how do we frame it? We start asking why. Instead of the vague increase sales, we narrow it down. The real goal is to increase the average order value. Okay, better. The business decides they want to do this by recommending more items. Now we can finally frame the data question: which 5 products is a user most likely to add to their cart based on what they've looked at and what's already in there. You see how specific that is? Now that's a problem a machine can actually solve. Okay, case study number 2. This one might sound a little familiar. A software company wants to reduce customer churn. This is the exact problem from my failure story. Let's see how we can do it the right way this time. So here, the business context is everything. The goal isn't just to reduce churn in general. It's to retain valuable customers who've been around for over a year. The plan is to offer them a special discount. So look at how precise the data question becomes. We're looking for customers who've been with us for more than a year with an 80% or higher chance of not renewing, specifically in the next 2 months. Now that is an actionable question that will lead to a genuinely useful model. Let's do one more, this time from healthcare. A hospital's goal is to give better, more proactive care. And this example really shows how high the stakes can be. Getting the framing right here isn't just about saving money. It's about saving lives. Now, the goal is to find high-risk patients. But how do you define high risk? In a real-life project, a team made a critical mistake. They used healthcare cost as a stand-in or proxy for health risk. They just assumed, hey, the people who cost the most must be the sickest. But that was a terrible assumption, and the model ended up completely missing some of the sickest people. A much, much better way to frame the question is to use the real data, medical history, and lifestyle factors to find patients at risk for a specific condition. It's a huge lesson in how important it is to choose your metrics very, very carefully. So if you forget everything else, just remember this one simple formula. It all starts with the business problem. You use problem framing to turn that into a specific data question. And that question tells you exactly what kind of output, what kind of solution you need to build. Problem to data to output. And this table just lays it out perfectly. A vague goal like sell more products, after you ask the right questions, turns into a concrete output, a list of product recommendations. Stop customers from leaving becomes a focused, actionable list of customers who are actually likely to churn. It's all about that journey from abstract to concrete. So, what's the game plan? What do you need to remember? First, you have to be obsessed with understanding the real business goal. Second, channel your inner Kirana store owner and become a master at asking simple questions. Third, always be thinking, what data do I need to answer this? And most importantly, remember this, coding always, always comes last. Okay, enough of me talking. Now it's your turn to be the detective. It's time for you to start framing some problems on your own. Let's try a couple of quick ones together. First up, imagine your favorite food delivery app says they want to deliver food faster. Okay, that's the big goal. But what are the clarifying questions you'd ask? What's the real data question they should be trying to solve? Hint, think about things like the delivery routes, how long restaurants take to cook, or even rush hour traffic. And here's the second one. A streaming service, like Netflix or Hotstar, wants you to watch more shows. They don't just throw a random list of movies at you, right? What is the super specific, data-driven question that they are trying to answer every single time you open up that app? And that really brings us to the final thought I want to leave you with. This way of thinking, this problem framing, it's not just for data scientists. It's a skill for life. So just look around you today, at your college, in your neighborhood, maybe even in your own daily habits. What's a vague problem you could start asking questions about and framing right now? Thanks so much for joining me.